And without any further delay, I think we should start. Over to you, Aditya.
Thank you so much. Okay, so this presentation, by the way, is courtesy of Emacs. I did none of this design. I was typing things in my org mode and then and exported it using org reveal, and it's great. It works pretty well. So composing Clojure web stacks using functional first principles, it's a big one. Also, by the way, I'm on two screens, so my camera is here and my presentation screen is here because that's a much nicer screen to view and present on. So I'll be switching from this to this. Um, okay, it's a mouthful. Basically, it means that what do you do when you don't have any frameworks? And in the Clojure ecosystem, it turns out that there are frameworks. I'll list a bunch of those later. But people tend to put together their web stacks, so to speak, and application stacks in general, whether it's desktops, whether it's front-end applications, whether it's games, or your full stack apps or backends, whatever it is. They tend to cobble it together with compose with a bunch of libraries. Sometimes it feels like cobbling, and that's usually when you get started because making choices is really hard, and it's very hard to do unless you have a good mental model. So hopefully, like this, I've been writing about this. So there's stuff on my blog. There are a bunch of study projects on my GitHub. All of this content I'll share with you. Um, and I'm going to dispense with like a self introduction because it's on my website. You can check it out at your leisure. So once again, welcome and let's begin. Uh, so this is the 6-point program. I'm going to do this in like two rotations. First, I'm just going to speed run through the deck and give you a feel of it. Then I'll share the link in the chat so everybody can have it open because like the slide, the section number 3, which is go to workshop content, has links to this presentation itself and other stuff that you can refer to at leisure. The link is public. Uh, uh, so I'll share it by after like the section third. I'll share the link with you because you can have it open as a reference for the demo. So here we go. All right, that's the Clojure logo. And in it is very stateful. So it has an exclamation mark next to it. We begin now. And I must give a health warning to people. Lisp sometimes hurts people's eyes, minds. Sometimes it's bad for people's health. So I've been told. Not for me. I love it. That's the approach. It's going to be my beliefs and my code. So it's all like real stuff. There's no magic. Everything is open. Commit histories and like whatever. I'm also available for long email discussions after the workshop. Simple doesn't mean it's a toy. Simple means it is composed of distinct parts that you can uh, examine independently, and they are loosely coupled. Uh, Again, I think Naresh has mentioned this. I'm calling it the law of mouse pointer. If you feel at any time you're getting bored or it's not for you or you have other work, please feel free to step out. That's one of the big advantages of being asynchronous. And please, feel free to chat. During the demo, I'm going to be speed running through the demo also. Uh, Let me just, mm, give you the breakdown of the session. Um, and, just like this breakdown happened to Kurt Russell, it could happen to you too. So the first, I'd basically, if you see 20 plus 60 is 80 minutes, I'd budgeted 10 for technical snafus, which have happened. So I'm going to move much faster. Um, so it's kind of a scripted live demo. And the reason I'm doing this in loops is because many of these things will be new to people, and repetition is useful to kind of let the details sort of slowly sink in and then connect with each other. Uh, so once I run through this speed run through this deck, I'll speed run through the demo, and this will be like me trying to live evaluate things and walk you through like a structured progression of things. After that, I'll flip the model around and then throw it open to the crowd. Because we are on a Zoom meeting, people can ask questions. You can make me, try and like, I'm sure that a lot of people in the crowd are very experienced web developers. So you can, make me struggle to answer your questions. Can you do this in Clojure? Uh, and then afterwards, we can spill over to the Hangout tables until they kick us out. I love hanging out over there. Optionally, you can share this stuff. I'll just drop this in the chat to begin with. Where is the chat gone? And this is what happens when user interfaces change a lot. It's under more somewhere. Oh, chat is under more. Okay. Ooh. What? Just copy this text. Don't want to copy everything. Yeah. Okay. Right. Share at will. There's no compulsion, of course. I will not be looking at the chat for the first 20 minutes. I'll look at it afterwards. That's the workshop content. All the links are there. And now we shall begin the demo. I'll walk you through the structure of the demo very quickly. The focus is primarily intuition building. Don't focus on things like syntax, parentheses, types. We'll cover that in detail when we have time to talk about those things. And also ignore my IDE, which is Emacs and developer tooling, etc. So the first project I'll walk you through is what I'm calling a null project. It's really, really empty. It does nothing. The idea is to let your eyes get familiar with things like a dependency file, what the structure of the code inside a file looks like, just to begin with. After that, I won't focus on these details too much. I won't tell you what a function is. I won't tell you what gen class necessarily means, etc., etc. And And then I'm going to show you the one of the many calling conventions. We are going to use this calling convention to run our stuff. There are many ways to do it because there are many tools available to run Clojure applications, including building a jar and running it as a regular jar, many command line invocations. So to keep it simple, we'll just use this. It works. Uh, After that, what I'll do is I'll take this null project and hydrate it a little bit with something more. Okay, I'll make some more structure apparent. And after that, I'll hydrate it even more. Like within this catch-all web application, I'm going to add a little bit of code, which is a web handler, because that's what we are doing. Like we're building a web stack, and then show you how to run it with a command line. And then kind of try to demonstrate this REPL-driven development concept, which is very central to the way we interact with dynamic live runtimes in Lisp, Smalltalk, APL. Erlang people do it in a different way. They don't, I mean, they'll do hot code swapping, etc. Their method is different. But yeah, and this, the reason I'm going to spend a little bit of time on this is because people people don't really understand, like this is the main place where people struggle, especially coming from types to a dynamic system. Then I'll quickly demonstrate how one would expand it to like a small web application. Mainly, I'm just going to add tests because I want to avoid scandals. We do something called REPL-driven development, and it's not necessarily the REPL that you think you have in Python or JavaScript or other languages. Kotlin, God forbid. And then I've got a bunch of applications. There's a bigger web application which I can walk you through. So this bit is not really part of the demo, maybe depending on the time we have. I leave this open for later discussion, but it shows a much more fully fleshed out application with a bunch of libraries. And then finally, if we have time, I'll go through a project management system that I'm working on. It's on the web. README is pretty, this thing. And the reason I'm working on it is because I relate to this guy. If somebody asks me to learn new tooling, I'll just do more work instead. And that's me doing some work. So there are a bunch of frameworks, starter kits, frameworks, project management systems. I'm calling Polylith that. It's a really good architecture. You should check it out. Very general purpose. And then you can choose your own adventure or misadventure, which I've done. And then I'll round up with a bunch of Clojure design, software design maxims. We love hammocks, and Richiki likes to point to things. One of the maxims we have is always be composing. We use it's just data a lot, but what does that mean? Decomplect is another favorite. rich abstracts, so you don't have to. This takes a little bit of explanation, and I'll walk through those also. And simplicity, which isn't so easy. It turns out that I have a very hard time explaining simplicity, so there's a lot of stuff, and that'll be all. Okay, so with that, I'm going to drop the link to the presentation in the chat because I know not everybody has Emacs, and so my org mode original will not really work for you. If you can access that link, please add a thumbs up, and I'll switch to the demo. Awesome. Okay. Uh, and this is basically the org mode version of the same thing. And I'm going to start Max. Huh. Okay. So, all right. So, is this font size visible to everybody? You can. I can make it bigger if you need to. Okay. Awesome. Uh, all of this stuff was set up. I had to reboot my machine, and it's horrible. Anyway, we are live now. So the left hand side basically follows this structure. This is my deck. These are the 3 quick demos, and these are the examples that I want to convey. Uh, the other thing I'll show you is I've also set up my terminal here for the project. So I'm going to start a REPL. Um, Again, ignore this calling convention. It's basically going to start me a read eval print loop that I can connect to from my Emacs. Here we go, right? And if you can switch to the null project, okay, that's the structure of the null project. In the deck, let me just open it here. Okay, so that's the code for the null project, and I'm going to move ahead so that you can. Okay, so that's the null project, and the idea is just to demonstrate the calling convention here. Uh, uh, Gen class, so like in the Java world, it's very common. I think it's common in pretty much any programming language that the runtime needs to be told where to look for the code to bootstrap the application from, the runtime from, not the application per se. And there's always a dunder name equals to main equivalent thing, and this is that thing. Gen class simply tells the compiler to compile this ahead of time, so that it's available at a well-known location in the jar file that's built, which we use. Um, this is typically the way we like namespaces, and this is actually a really bad namespace because namespaces should be a good namespaces are globally distinct. So you will have com.foo.bar is going to be your namespace, corp or whatever it is, like something like this. So it is, you can resolve it globally. App, it's, ChatGPT will basically make app namespaces as many times as you want, and our code will all overlap with each other and blah, blah, and whatnot. So global namespaces are bad, but globally unique namespaces are good for reasons of code separation. Okay, and then this dependencies file is nothing. Uh, uh, in what the important bit to understand here is that this open close brace is a Clojure data structure. It's a literal hash map, and we'll hydrate it in the next particular application. So what I'm going to do is go back here, and now I'm going to connect to this this running server. nREPL is a tool. Again, I don't want to focus too much on it, but it sets up a live runtime which I can connect to, and which is to begin with identical to the code, the live versions of the code that are like written on it in my files. So I'm going to connect it from my editor, and it picks it up. So just double checking the port. Yes, it's got that. Uh, okay, so I'm going to load the content, and then I'm going to call main, which does nothing. Okay. I've just evaluated it inline. I'm using some shortcuts. They don't matter. But the fact is that when I evaluated this, it's evaluating against this live runtime. This can be a production runtime also. And there are legitimate reasons why you want to connect to a live running application in production for debugging purposes or like inspecting stuff that's going on live without destroying the state of the system. Take some tooling and take some care, but you can do it. Uh, so like these are the different moving parts. There's one live runtime which I connect to, code I can evaluate against that live runtime, dependencies which are just Clojure data, which I can hydrate later and specify later. And your ID and all of this stuff is just incidental. Uh, Go back here. Okay, so now we are here. Main doesn't do anything. So let me make it. Okay, evaluate this again. So every time I edit code, I'm going to evaluate it live. And now when I evaluate main, it's going to return hello world. But let's try to see what happens when I use this calling convention to call it. Okay. Um, whether, so actually, let me do this. I've saved the file. I'm going to call it. Split the screen and copy this thing, paste it here. Okay, it did nothing. I'm going to start adding code back here. So I've added hello world, evaluated this. I'm going to show you that it actually works. It returns hello world. And then I try to run this again and still nothing. The reason for this is all code are expressions. And the last part of the expression, the body of the expression evaluated is the return value by definition, by default. And these are pure functions. So there are no side effects. It turns out that printing is a side effect. And when I evaluate this, now you're going to see this thing return nil. Why? Because the return value of printing is the last item in this form as expression. Print is a side effecty thing, and its return value is void, null, empty, whatever. And it causes things to appear in the read eval print loop. You see this? So I just opened a side pane, which is echoing things to me in context in my editor. So when I evaluate main again, it's going to have these side effects. And it's literally updating the state of the buffer. Okay, therefore, QED, etc., etc. But now, and why do we want side effects? Because we want applications to do something useful for us. And now our application is going to be able to say hello world. I will also increase the font size of this so it's better. Right, so this was demonstrating the calling convention. All this code will be available. I'm going to quit this REPL, go back to the demo, and move ahead to the catch all web application. Go there. We are done with the null project. I'm going to just collapse this so that it's not messy anymore. All right, so the catch all application, once again, I will go to the main namespace. And this time is different. So compare, the code is going to flip in this window now. This is our old null application. And I'm going to open it here to the catch all application, and boom, there's a whole lot more code. And I'm going to explain what this code is supposed to do. The idea here is to show to you that simple is not toy. So one of the things that we've done is to add dependencies. So we've specified things to add to the class path. This is required for build tools, which I will demonstrate in the next application, to package source code, any compile classes, any library dependencies with pinned versions. And you notice that our programming language itself is just a library. And in our projects, we like to pin the dependency to a particular version of Clojure. Even though Clojure is very, very, very backwards compatible, I could bump this down to, let's say, Clojure 1.8, which I think is 5 or 6 years old, and not worry about more or less anything except for JVM specific dependencies. I think Clojure 12, which was released a couple of months ago, I think 2 or 3 months ago, supports up to JDK 11, if I'm not wrong. And JDK 11, so it's usually like a 10-year window of JVM runtimes that the language supports. So unless you're doing something very, 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 high, like bleeding edge, you're likely to be very safe backwards compatibility wise. The other thing we are using is an adapter for the Jetty web server, which comes from this project, the Ring project. And this is going to parse and unparse HTTP object information for us. Its job is to let us express HTTP request response as plain Clojure data, which looks pretty much like this because it's just hash maps. And this is one of the very important design choices that the Clojure build tool has made, that everything is expressed in the first class data structures that the language itself supports. Okay, so hash maps and vectors and strings and keywords, these are all atoms. This is a keyword. Okay, this is a string. This is a vector of strings. This is a hash map with keywords as keys, where you can nest other hash maps arbitrarily. Okay, so this is just plain Clojure data, and this is a symbol. Okay, EDN stands for extensible data notation, and you can add reader macros like my version. Okay, and then you can write an interpreter for this data, which enforces some guarantees when it notices this tag in the file. The other thing we can do is we can add comments, which you can't do with JSON. And the final thing is we can serialize this data, and we can send it over the wire. So Clojure applications can talk to each other with EDN. There are ways to compress this data for transit. I think transit is the format that does a lot of this compression. It relies on the fact that these keywords are interned, which means keywords are like, once a keyword is created in the JVM, it's a unique object. Identical works on it always for the lifetime of that JVM session. Okay, so I'm now going to kill this guy because we're done with it. Going to go to catch all app. Okay, I'm going to do the same thing. M cider. Oh, did I make a mistake? I must have. Oh yeah. Okay, you see, so it refused to start because I added this literal reader of my this reader macro of my own, and this reader macro is custom. It has no definition in the default implementation of the tool that reads the deps.eden file, and so it's complaining. Okay, it says it found my version. Look at this. It found this reader macro against this hash map, but it expected a map. Okay, so it's refusing to parse it. It's telling me why it's not parsing it. So let me get rid of this. Amazing. I never intended to make this mistake, but I'm happy I did. So note that I killed the other REPL session and I've started a new one. I'm doing this for my sanity and everybody's sanity because I can't. I can, and normally I intend to work against multiple live applications at the same time from the same editor session. But I want to keep it separate for obvious reasons. Okay, so the catch-all application, again, I'm going to do the same thing, connect to the live session, Control C, Meta C, local host, picks it up. I'm going to load the file in that thing. Okay, now compared to the app.clj, app.clj simply had a gen class there. This has something more. So gen class is there. Why? Because there is a main. All right, this main is there, which is running again. Now this is doing some real work for us. It's not just printing hello world. This is the syntax to tell Clojure that this namespace, specifically this namespace, which I've identified by org eval apply catch all app. It's a 3-segment namespace which because I own the domain org.eval_apply, it's my responsibility to guarantee that if I ever publish this application, put it in public hands, that this name stays constant. And I'm required to do that because if I have to publish to Maven or Clojars or uh, mm, um, any other Java application repository, I am bound by social contract and the contract of the ecosystem to not break this namespacing system for the life of this application or library or whatever it is. So, okay. So we have a bunch of things. We have a handler, which is a which is going to accept a request. This request, by the way, is going to be a hash map. And we'll see the structure of the request eventually. Uh, the hash map will basically be one-on-one correspond one-on-one to HTTP requests. Okay, and I'll demonstrate that with a curl. Uh, so just like this thing did a side effect at the end, this thing is going to return it's going to construct a hash map with status 200 with some headers, and it's going to take the request and echo it back in the body just as a string. This function runs the Jetty server. And I want to do this because I want to be able to run it on the command line and also use it from my my REPL. So I want to start two different servers running the same code on two different ports. I don't want a port conflict. So we got this. And now I'm going to do, I'm going to take this and run it. Okay, so I've split this again. Namespaces with dashes use underscores. What? What did I do wrong? Oh, I think I accidentally stopped sharing.
Your screen is visible, Aditya.
Okay, strange.
I can see your editor with catcher app.clj.
Okay, cool. Okay, I thought I'd made a mistake there. Now what's happening? Yay! Oh, of course, because I'm in the wrong directory. Haha. Now it should work. Ah, thank goodness. Oh, let me go and check that. Ah, okay. Right, so when I opened the new pane, it opened it in the null project. I'll have to watch for this. Q1. Anyway, so now we have, you see this, I called the M stands for call whatever is main in this namespace. And the Clojure tool, this is the Clojure distribution, default distribution that comes with a bunch of tooling. You can ignore this. I've not configured a logger here, so it's going to keep complaining. We'll fix that later in another app. And it started the Jetty server at this port. So localhost 3000 should return me some information. So this is PRSTR data. Might be easier to see it in a browser. Okay, that's that. So if you are familiar with reading raw HTTP request response data, this stuff will be familiar. The response contains stuff about client certificates, which host it's come from, the IP of the remote host, any headers that were sent back, and some body, which is, yeah, so there's a content producer, some sort of a streaming response object. It's just printed the literal thing of this. Ideally, you would be serializing HTML or JSON or some concrete entity and sending it out in the response. And of course, there's an HTTP. The request method was get. because I'm echoing the request. Sorry. Yeah. So I'm echoing the request in the response. So this is request data. Okay. And this, by the way, is literal Clojure hash maps. I can copy this, copy it here. I can go into my file. I can say def call response is this, right? The body will probably cause me some problems. What I'm going to do is I'm going to evaluate and print this out. Yeah. Okay. So it's giving me the same error. No reader object for no reader for tag hashtag object, because it thinks that this syntax is a reader macro syntax. So I'm just going to get rid of this and say hello here, and then print it out. All right. So I pretty printed it in a buffer on the side, and you can see that it echoed the request as is. And let's compare it with a something's up. Okay, so let's compare it with this. I'm going to do a verbose curl, and let's do more verbose curl. Okay, so that's the request. That's the get request coming from this local host, from user agent. And you'll notice that a lot of this information does not appear in the original request. Much of this was added by the Jetty adapter. Its job is to enrich the request response payloads for either me, who is the consumer, or consumer on my side, which is my program, or consumer on the other side, which is the client. So this thing is sitting in the middle. Get rid of this. Go back. Okay. And if you've noticed, I've done a bunch of this is all live. Okay. So now I've captured request response data locally. Let me run a couple of more curls. I think I have a couple of curls here. F10, F10. Yeah. Okay. So that was just a get request. I'm going to run a post, and surprise, surprise, the query parameters are going to appear. The URI is going to appear here now. So the Jetty adapter noticed that there is some information present in the URI. So it's going to expose it for me. It's exploding out all the information for me. And the same thing, if I have something with query parameters, it's going to stick that in here also. Let me go back to the no curl, please. All right. So as you can see, the search parameters appeared in a query string. All right. And what the Jetty adapter is doing is it's conforming to a specification, written down specification and machine checkable specification from the Ring project. Okay. So this is the other moving part now. And this is our basis of composition, because what the adapter has done is it has taken something that is uh, what do you call it has taken something that exists as very, very concrete typed objects in the Java world and converted into something that's a very, very general data structure. Okay. So if I want to look up the URI from the response, okay, I can simply do this because a keyword has function semantics. It turns out that maps also have function semantics. So because what's the simplest function is a lookup table. A pure function is a relationship between a left-hand side and a right-hand side. And that's what a hash map is. So in Clojure, the hash map has function semantics, and I can look it up like this. And if I think there's some messy thing going on here. Ta-da. Method get, right? Oh, sorry, not get response. All right, so it's giving me the request method get. And now I can start making decisions. All right, so I could potentially have a case statement, which is looking at the request method, okay, and saying, what do you do if it's a get? So I'm going to now convert this into a tuple, okay, of the URI response call, right? And I'm going to match on that, the get and that, right? And I'm going to say hi. Otherwise, I'm going to say boo, and it returns hi. Okay, so for the simplest web application, you don't even need a router. And there are people who are running web applications in Clojure with more or less just this, like Jetty adapter and a bunch of other libraries, and they are off to the races. Um, you'll use a battle tested library for doing things like crypto or authentication or any of that stuff. But once you have your request response as generic data, then you're basically free to do anything you want with it. Uh, and because these are, this is that point, rich abstract, so that you don't have to. The data structure itself is very general. It has very general semantics, and is generally composable. It's an any to any, where any implies this particular key can be a string or a keyword or a function because functions are values. The key can be nil because nil is a value. Uh, the key can't be a side effect, of course, because I don't know how to do things with side effects as keys. Uh, um, and it can be arbitrarily nested. So I can have a map where this itself is the key, and I can say I'm going to do something crazy. Okay, so where did my Emacs go? Sent it on the wrong screen. Sorry. Is it visible now, the Emacs? Someone unmute and say yes.
Yes, it's visible.
Okay, cool. Yeah. So the crazy thing I'm going to do is I'm going to make this the response itself the key, and I'm going to say a response. Okay, and then if I say, okay, so I've reevaluated this. Now I'm going to say response curl and return me the thing using this as a key, and boom, it returns a response to me. So just to show you the value of having these very general data structures. So it's possible to model your domain very flexibly. And one of the domains we've modeled over here is the domain of HTTP. And we model the domain of HTTP relying on the Ring project specification, which you can see in the Ring project itself. Okay, moving on. So we've set up a basis for routing. We've set up a basis for general applications. Uh, one more thing I want to impress upon you is I'm going to start another Jetty server instance, and I'm going to call this. So this is the object we have, blah, blah, something. Uh, but I can query the object itself, all right? So I'm going to query what's in this object. And the reason I'm querying a Java object is that it doesn't really matter the details of this, but the point is that uh, this is the meaning of having a dynamic and live system, that you can query your live objects even if they are from the host, because Clojure is a hosted language. We are using JVM Clojure, but there's JavaScript Clojure, there's Clojure for .NET CLR. There is a compiled Graal native, is great because all JVM projects benefit from it, yada yada. So there's a whole bunch of things. Uh, Another way to dynamically work with your system is to capture values. Here I capture the value by hand from my REPL, but here I'm going to set up a thing called a tap. This is part of the standard library. And the tap again is general because it's just your code. You can define anything. So I'm going to say I'm going to start collecting responses in this atom. Okay. And I'm going to define this function. Atom is basically a stateful entity which lets you do atomic updates to whatever its value is. So this capture response is going to start appending. Okay, conj means append in the case of a literal vector. So it's going to keep appending responses after for any action done on for any action done by tap, right? So I'm going to say going to show you that responses is empty right now. This atom contains an empty collection. Uh, imagine for a moment that I'm going to say capture response. Okay. Oops, sorry, not capture response, the response. Responses. We have multiple. Okay, so this is basically a boxed value is boxed inside the reference semantics of an atom, and I can get into the value by something called dereferencing. So we say deref responses. Okay, there you go. All right. So because I've tapped only one value, tapped once, is this, and let's say by, and I'm going to deref responses. So boom, now you have high and by. All right. And this is a very useful built-in method for inspecting live values and live objects. We can also do things like this typically is useful when a project is just getting started or midway you're refactoring something. You know, try maybe another some other alternative library without temporarily just for the session. So we have something called REPL depths, which again comes with the standard library as of Clojure 12. Uh, before Clojure 12, it's available as a backwards compatible add-on library, which you can use. And then I'm able to add things like Clojure data JSON, blah, blah. I evaluated this. I think it's going to take some time. Okay, so all right. So these libs have been added to my current runtime. I can require this, and I can say that JSON read no right. Okay, I'm going to take JSON write JSON and just quickly because I forget the API, I'm going to check send it a hash map. Expects 3 arguments. Okay, why does it expect 3 arguments? Oh. Let me just use JSON write. What's it doing? X. Oh, it needs a writer. Mm. Okay, let me see if this works. Okay. Huh. Print. I forget the API for this, but basically the point is that this is why I should have had some code here. And I'm sleep deprived, so like I'll figure this out. I mean, at some point, but you can make a JSON writer, and so presumably write string needs. Yeah, but write string. Oh, okay. Yes. Thanks, Apurva. Okay, so write string does the magic for us. That's what I was looking for. Okay, so a thank you, save my life. Life coding. Okay, so we have JSON here, and now what I'm going to do is I'm going to say temporarily, because I don't want to change how this actual echo handler is working. I'm going to copy down this body, okay, over here, and I'm going to say that take the request and write it as a JSON string, and I think this is text JSON or application JSON. Okay, so now our echo handler has become a JSON API. Body JSON API. That's all right. So now I've evaluated this, and hopefully that means that the curl that I run will be I have to restart this thing. Okay. But I don't want to restart that thing because I've already got a server running here. And I can do everything from my thing here itself. So I've defined the base URI as localhost, and I'm going to get this localhost here. Boom. All right. So we see the body is a JSON thing, and I can say that take this body. Okay, because I've seen now I can inspect. Where's it gone? Okay. I can inspect this. I know this is a hash map. And so I know I have lookup semantics. So I can say, take this hash map, give me the body. Why? Oh, yeah. Give me the body. All right, the body is this. And now I think I should be able to do JSON read JSON. Why? str. What happened? JSON slash. Oh, I'm not sure if this escaped or not or what. Non-string object. Let's see, read. And let's see, read str. Okay, something I'm doing wrong, but you get the point. Basically, this was the longest part of the demo because I wanted to demonstrate this very interactive, dynamic way of working with your system. I'm going to move on. So here, this is the final demo. I'm going to expand. So far, we had just one namespace. I'm just going to add a test namespace, some more dependencies, because builds are programs. This is the other part of composing your own web application stack, that you rely on the fact that these things are just code and functions, like data and functions. Okay. So where's it gone? 1, 0, 3 max. Yeah. Okay. So I'm going to exit the catch-all app, and I'm going to go here. We've kept the same concept of global namespaces. Here again, I've removed the comment form because I'm going to do something different with this. And I'm going to get rid of this particular REPL, kill this, kill this. How are we doing for time? Wow.
We have 20 minutes with us.
20 minutes. Okay. So I'll just finish at the end of this. All I wanted to show you here was, because that was the main part of the demo. It's that and some more stuff. Okay. The some more stuff is writing things that will start doing more work for us. Instead of writing a case statement for a whatever, get this, right? I can use something called a multi-method. A multi-method is a open-ended mechanism, dispatch mechanism, and I've added another namespace called the router, which I'm calling the router here. Okay, the router looks like this. This, by the way, is this example I've purposely taken from what has become a canonical example in the Clojure ecosystem called User Manager, written by Sean Caulfield. And there, Sean has defined a bunch of routes, etc., etc. So I've kept it like this. So it gives a mostly one-to-one comparison between example to example. It's a pedagogical tool which I like. So this is the multi-method. What it's saying is, forget this bit. It's saying that from whatever request information is passed, lift out the request method and the URI. This is a form of destructuring, which says that please find keys with these names inside this request. And also, by the way, please bind the value associated with the request method. So inside the hash map, the request method will be a key, but inside our function, it'll be a name, like a symbol that is bound to that value. And here we are going to get request method. And now I can perform whatever transformation I want on whatever part of the request I get. So in this case, I'm saying now please start matching on tuples. Okay, so this is identical to the case statement, except I'll do things like anything that is a number. Okay, please replace it with an ID for whatever reason. I mean, this can get as sophisticated as you want. And that's the basis for quote unquote production grade routing, because once these matching rules become very complex, you need a production grade matcher, uh, which means that it's going to be able to disambiguate a lot of stuff coming from your request stuff, request data, and it's going to let you give you a very convenient API, so that you don't have to do this manual like string munging, blah blah. So uh, by default, multi-methods let us specify if fallback option. So we can say that if no case matches, please return a 404 not found. And if you can see, this is just little Clojure data. All right, this is nothing. This ignoring underscore means ignore the handler, ignore the request. The method has to comply with the API that the implementation of the method has to comply with the API that I've defined over here. That's all. But this thing is just returning plain data. And these are matching on all the different cases. Okay. And the advantage of this is if I ship this application as part of a bigger application, then the consumer, let's say I ship it as a library, and the consumer wants to start handling request response patterns that I have not catered for. They can extend, because this is an open-ended polymorphic system. They can extend the functionality from outside and write their own. So suppose they want to handle get reset some other way without messing up my implementation. Okay, so they can be in their NS acme com dot acme dot whatever foo, and they can say def method router. This is their namespace. So this router definition will sit. Okay, this is their implementation. It's the same name. Okay. And so what they will do is they will they'll reference my my router implementation. So they'll say org dot eval apply dot router dot core slash router. Okay, so now this is a globally resolved name for the router that I have defined. And because they want to consume a router, my router, but they want to add their own behavior to it, they can trivially extend the routing mechanism and use this. Okay. And then if they want like convenience, for convenience, we let people, there's a way to alias these things. So I can say require this as EA router. All right. And so in their code, they can, let's call it EAR, smaller alias. Okay. And typically by convention, like the more frequently something gets used in a code base, people give shorter names. So now, again, this is again the basis for composing different systems with each other in a very open-ended way. This is not monkey patching. This is not going inside and modifying any object under the hood. The polymorphism in Clojure solves the expression problem, and we can talk about that in depth later. Uh, and again, I can similarly just locally test these things, but I also have a test namespace, which is doing a bunch of test things, all right? And I can prove to you that it works by, Now here is one small detail. This dependency specification method, let's just say that globally for the application, I want to describe these parts and these dependencies. But in my developer context, I want a HTTP client. And in my test context, I want a test runner. And now I can say, call this, saying that please execute whatever is under this alias and this alias in the dependencies file. And hopefully test run. Okay. Ran 2 tests containing 11 assertions. All this code will be available, and I'll stop now and go back to free form discussion. Okay, this took much longer than I expected, but yeah, hopefully it was useful. Please feel free to unmute, say things, or drop things in chat if you don't want to appear on video. And I'm available all evening in the Hangout room. I'll stay as long as they let me stay, and we can hack on something live over there if you want.
Thanks, Aditya. Anybody, if you have, I have given the permission to everyone to unmute themselves. So if you have any questions or if you want to chat to Aditya, you can unmute yourself and you can talk. And if you're not able to somehow, then you can raise your hand and I'll, ask you to unmute yourself.
By the way, I know I went very fast. I purposely went very fast because you can slow me down in the recording and you can pause me in the recording. So have at it, or anybody can.
It was fine, like it was understandable.
Hmm.
Yet again, anybody, if you have any comments, you can ask in the comment section as well.
Okay.
If not, then we are good. Thanks, Aditya. Thanks for sharing your thoughts and experience with us.
Yep.
It was a very insightful demo. And everyone, as Aditya already mentioned, he will be available on the Hangout section. The Hangout section, the table name will start with his name. You can join it and you can video chat with him. And here, please, when you leave this session, please rate it. And also, there are around 150 people across the globe in this event, and it's a great networking opportunity. You can grab a seat at the Hangout section, and you can also find everyone and you can chat with them in the mingle. Please make direct connections directly by messaging them, and don't forget to check who has reached out to you. And so, which section are you attending next? Check the live stream page to see what's coming up, and let's meet in the Hangout section. Yeah. Thanks, everyone. Thank you, Aditya.
Awesome. Thank you so much. Yeah. By the way, three links in the slide are going to 404 because they link to these projects, which I have not pushed to remote yet. I'll do that by the end of the day. I want to make sure that the code is runnable. And I noticed that there is some comment by Caio Cesar in the chat. I'll make sure that I address that also, so that people don't have these problems. And my email is available on my website. I'm very, very happy to have these rambling conversations about things. And also happy to get on sessions one-on-one with anybody who wants to, try out Clojure in general, not just web applications. And sorry, the last bit I want to say is, please look at these resources that I've in the end. There you go. All right. Because this is like this, the reason I went through this whole null project to somewhat bigger project process in front of people was to show that you don't really need a framework to start doing something useful. The echo handler itself is a useful thing because you can run it in your, let's say, your build system or your CI system to make sure that your tooling is set up right, your builds work fine, any health check that runs as part of the CI works. And so for that, you don't need like an entire framework. You can just have this really, really tiny app. And because it doesn't have any of the other machinery of your canonical framework, but it has the core component, which is your web server and your the wrapper on top of the web server, that gives you a lot of confidence that anything that's built on top of this will at least pass the smoke test in the CI build. Uh, so yeah, so like from a systems point of view, uh, this has a lot of leverage over a period of time, because instead of starting from a very big batteries included framework, you can start from the smallest set of things that you need, and then slowly accrete, right? Grow things in a way that you can maintain over a long period of time. The trade-off is that a lot of upfront thinking is required, a lot of upfront planning is required. So for that, a bunch of these, frameworks and starter kits really help. Dep's new, I see Sean. Thank you, Sean, for creating Dep's new Next.jDBC and a bunch of other very cool things. Polyliths. He's also doing a lot of work on documenting explanations for Clojure. And I think the more than I don't believe the Clojure ecosystem needs frameworks per se, but we need really good explanations. And explanations also come in the form of frameworks, because these like Zodiac and Caveman are step-by-step guides for you to start composing your web applications from scratch. I went like one level below these because they start with libraries. I went below libraries. So instead of using a library for routing, I showed you, you can just use multi-methods, like your standard library. Clojure standard library is enough, as long as something in the middle converts Java objects into maps. Okay. Ta-da. So look at these. Caveman is entertaining. Zodiac is very, uh, it's, deceptively small and simple, but it lets you, accrete your application, which is very powerful. Um, per using of Dep's new templates will also um, get you familiar with some more of the Clojure ecosystem and the way people set up applications. When you have data and functions, you don't really need to explicitly think about model view controller, etc., etc. As long as your functions are pure and your data is composable and your functions are composable, like the architecture sort of evolves around it. Applying MVC, MVCC, MVMMC is optional. You can do that for design reasons, okay, but you're not compelled to do it from the get-go. You can structure your code however you want in your directory and be on your way, right? These are much more sort of batteries included frameworks, but really they are opinionated collections of libraries. Jacob O'Brien thought that he needs a set of libraries as a solo developer, so he built BIF. Weave Jester has been building lots of amazing libraries in the Clojure ecosystem. This is by Dmitry Sotnikov and a couple of other people. SideFox, I forget the author's name, but this is a full stack uh, application that runs on the Node runtime. So people who have that restriction have an escape hatch completely, because once again, Clojure scripts, the JavaScript land dialect of Clojure runs on the Node VM. There's Hoplon, there's Hyperfiddle. These are very cool things that I don't think Hyperfiddle might not be possible in most other language ecosystems, because it's doing some very freaky compiler magic over the network. Definitely look at that project. Sean has built Polyliths. It's for, you have a team that wants to scale their application code base. They want to build lots of applications while sharing common patterns, common semantics, etc., without having to publish libraries and without having to get into that, insane diamond dependency problem that happens when you start managing your own dependencies. Also, like me, I want to choose my own adventure, because I have somewhat different goals from Polyliths. I would choose Polyliths in certain situations. But for a solo dev, I think I've been I've taken a lot of inspiration from Polyliths, but made a mm, maybe a half-assed, very reduced version of that works for my specific needs. So yeah, and this is totally up to you, because again, we follow these principles: immutable data, pure functions, open-ended polymorphism, specifications and contracts. Thinking in these terms lets you decouple systems, um, uh, and thinking in terms of lifting domain concepts out of executable code into plain data is another powerful thing. Why? Because like I showed, we can use multi-methods, or we can box those data into things called records. If we want single type dispatch and we want JVM optimizations, hotspot optimizations around that. So like we have a bunch of options to do this stuff. And my contention
Sorry
is,
to interrupt.
yeah,
I
are we
just want
for
to, I
time?
think we have 3 minutes more.
Yeah, okay, I'm almost done. My contention is that we can do better and cleaner object-oriented programming in Clojure than we can do anywhere else. Decomplex, like these are all, mm, things that you'll hear in the Clojure ecosystem. That's why I put them there. And finally, like it's really important to come at software development in the Clojure ecosystem from the perspective of the people who are maintaining the tools, the core team, as well as the ecosystem, because they share the same values in terms of stewardship of code, in terms of how software ought to be designed, etc., etc. And again, like this is part of the inevitable starting friction of uh, getting involved in Clojure. Experts also, people who've been building Rails apps for like years and years, they find it hard to get in because of this point of view. It's a very different a point of view which has day-to-day implications. It's not just philosophical. It's, it shows up in your command line tools, etc. So, and it's a trade-off. It's friction for some other benefits. Also, I'm available for hire. Hit me up if you want to build, that micro-SaaS you want to build. Yeah, and that's it. I'm done.
Thanks, Aditya.
Thanks
Thanks,
again
everyone.
for your
Yeah.
time, your patience, your kind attention, especially people who are up very late in the night. So, yeah, see you.